Hello guys, it's me here, Concordia Diquitos. Today's video is about the question of the child, whether she is the daughter of her parents or not. So, let us solve using the Dihybrid Cross by Gregor Mendel. And then we will be using the observable traits of the child. And this is the height, which is short, and the type of hair, which is kinky. Okay, so let us solve now. Dihybrid cross means crossing over two traits of both parents. Example, height and hair type. This dihybrid cross also is an example of Mendels Law of independent assortment. Okay, so now what does Mendels Law of independent assortment mean? Now this states that the two alleles of two or more different genes get sorted into gametes independently of one another. Now example, the tall man with kinky hair. The genotypes of this is capital letter A and the small letter B. And then, next to that is we are going to get the common gametes. And the common gametes are the capital letter A and the small letter B. Now, as you see, they don't affect with each other. Okay? So that is an example of independent assortment. Okay, so now we will try solving a problem using a dihybrid cross. Now, the problem is a homozygous tall with kinky hair man marries a homozygous short with a straight hair woman. Question, what would be the possible height and type of hair their children have? Okay, now we will get the phenotypes from the problem. Okay, so tall with kinky hair man and short with a straight hair woman. Next to that is we will be getting the genotypes. And the genotypes are, now for the tall, it is capital letter A. And for the kinky, it is small letter B. And then for the woman, the short is small letter A. And the straight is capital letter B. Okay, so those are the genotypes. Now next we will get the gametes. The gametes are capital letter A and small letter B. And for man, and then for woman, small letter A and capital letter B. Okay, so as you look at it, it is the example of independent assortment, meaning one does not affect the other. Okay, so next is we are combining the common alleles. Okay, so that is capital letter A and the small letter A, and then capital letter B and small letter B. Okay, so these are already the genotypes of both parents. Okay, so next to that is we will be solving using the Punnett square. Okay, so now we will copy the genotypes of the parent, and then we will extract also their gametes. Okay, so the gametes are the following. Okay, so where did this came from? The capital letter A and the capital letter B came from the genotypes of the parents, like that one. And then next is the capital letter A and the small letter B is also coming from the genotypes of the parent, like that. And the next is this one here, the small letter A and the capital letter B from the genotypes of the parents. And the last one is this one here, the small letter A and the small letter B. Okay, so now these four are the gametes of the parent. Okay, next is we are going to transfer the gametes of the parents. Now, the left side are the gametes of the father and the upper part are the gametes of the mother. Now, next is we are going to solve for the genotypes of the children. So, the first pairs are the capital letter A and the capital letter B. Next to that are the capital letter A and capital letter B with the small letter b. Then, next is capital letter A with the small letter a and capital letter B. Then, next is capital letter A with the small letter a and capital letter B with small letter b. Then, next is all capital letter A and capital letter B with the small letter b. Okay, next is all capital letter A and all small letter B. Okay, so next is capital letter A with the small letter a and capital letter B with the small letter b. Next is the capital letter A with the small letter a and all small letter b. Okay, so next to that is the capital letter A with the small letter a and all capital letter B. Then, next to that is a capital letter A with the small letter a and capital letter B with the small letter b. Then, all small letter A and all big letter B. Okay, so next to that is all small letter A and capital letter B with the small letter b. Okay, so next is capital letter A with the small letter a and capital letter B with the small letter b. And then next to that is the capital letter A with the small letter a and all small letter b. And then all small letter A and capital letter B with the small letter b. Okay, and the last one is all small letter A and all small letter B. So, these are the genotypes of the children. Now, if the letters are capital letters, they are all dominant. And if it is small letters, they are all recessive. And if it is a combination of a capital letter and a small letter, meaning they are the carriers of both traits. Okay? So now, we are going to get the phenotypes of these genotypes of the children. And then, we are also going to get their ratio. Okay, so we'll start now. The blue colored letters, they are all tall. And the 3 of these are having straight hair. And the 6 of these are having curly hair. Then the red colored letters are still tall, but all of them are having kinky hair. Next are the green colored letters. So these are all short. One of these is having straight hair and the 2 of these are having curly hair. And then the last one is short and having kinky hair. Okay, so we will give the summary on this. Okay, so now we will have the summary. Now the blue colored letters are, these are all tall with the straight hair and tall with the curly hair. And the red colored letters, 3 tall with the kinky hair. And the green colors one short with the straight hair and two shorts with the curly hair, and the last one is short with the kinky hair. So these are the summary, and then the ratio of this is 9 is to 3 is to 3 is to 1. So this means that 9 of the children are tall. 3 of these are having straight hair, and 6 of these are having curly hair. And then another 3 of the children are tall but having kinky hair. Then another 3 of their children are short. 1 of these are having straight hair, and the 2 of these are having curly hair. And 1 is short with kinky hair. So after solving, the question of the child is solved or answered. Yes, she is the daughter of her parents, and she inherits the recessive traits of both parents. But there are still many other traits that the child can inherit from their parents. The child performed well in school. She graduated valedictorian in elementary, valedictorian in high school, and cum laude in college. So you see, no two individual is exactly the same. Each one of us is born unique. Genetics explained well about individual differences, about hereditary traits. Okay? So, that is all, and I hope you learned from this video. And please don't forget to like, share, and subscribe. Bye-bye!